Hey guys, so in this tutorial I'm gonna show to you how you can add, remove rows and columns from a data frame. The first thing you want to do is import pandas as PD. After that you want to specify some kind of data frame. You can use your own one or use this one. Okay, so you wanna be specifying this data frame, so shift enter to run the code and boom, we've got our data frame here. We have 3 columns and 3 rows. So the first thing we wanna do is try and create a new column using the existing ones. So let's see. Let's say that we want to combine the name and the sex columns. What we wanna do, because these are strings, is actually add them as strings. So we call the df name, we use the plus, we put a space between those 2 columns and again call df sex. So essentially what this is gonna be doing is use this column, add a space, and also after that add the column sex and return a new object. Okay, so that's essentially what this code did. And you can actually use it to add a new column here. So what you do is very, very simple. We say extra column, we say data frame, brackets, extra column, you can use any name you want here, and it does not need to exist inside the data frame. This is really important. It will by default create a new column if this column does not exist in your data frame, and you want to put it equal to the column we created above, and then print out the data frame. Boom, you've got the extra column, which is a combination of the name and the sex. Now let's see how you can remove this, let's say, column. What you do is very, very simple. You use the dataframe.drop method. You use columns argument equal to a list which will be extra column. So what you do is specify a list which will include the strings, or actually let's say the names of the columns you want to drop. And because it is columns, we use the argument columns. And you also can specify the axis equals to 1, which means columns, just for safety reasons. Okay, so let's print out the data frame. Oh, wait a minute. Why is the data frame not having changed? We use the .drop function. Yeah, as we've seen in previous tutorials, what you want to do here is specify an argument in place. So in place argument by default is false because the .drop operation returns a new data frame. But if you use in place, what this operation will do is go into the memory and change the data frame object as it is in the memory. So let's run this code again. Boom, you can see that the data frame object has actually changed. So if you want to change the actual object and not get a new one, what you want to do is use in place equals true. Okay, so let's talk a little bit about .append, which is a deprecated function that you won't be using in the future, and I just showing it to you for encyclopedia reasons, let's say, just for knowledge. .append allows you to append rows to a current object. So you call data frame .append, specify, for example, a dictionary. I will call it dictionary. You can use a dictionary for this, and you specify for each column the values it is going to take. Bear in mind that the key of the dictionary will be equal to a column in the data frame, and the value should be a list because it should be an iteratable. So here I will specify that the new row I'm going to be appending has the name George. It will also have a value for age, which is going to be 25. And after that, I'm going to be specifying its sex. So it's going to be male. And it's going to be male with not capital M. And boom, this is how you can append a new row to the data frame. Oh, wait a minute, an error. You need to ignore the index. Okay, so if you want to append a dictionary, you need to ignore an index. If you had, for example, been appending another data frame, it could be able to use the indexes. It would be able to use the indexes of the 2 data frames. And also you can see here that I made a mistake. In this case, you may not want actually the list example. And as you can see here, we have appended the new row. And again, this is deprecated, it will be removed, so use pd.concat. Okay, so let's use pd.concat to concat. Okay, so let's use pandas.concat to do the same operation. And I really like this operation here with .concat. So let's specify the new row. It will be equal to a dictionary. And now let's specify the dictionary. So for the name column, we want George. And right now in this case, you want to use, the list specification using the brackets. Then you want age, which is like that. And age will be equal to 30. And then you want to specify the sex of George, and it will be, let's say male. One thing I want you to note here is that .append does not do operations in place. So if you print out the data frame, it will be not new. It won't have changed. The data frame, the original one, using the .append has not changed. If you want it to change, you need to do data frames equals data frame.append. Okay, so that's also one of the reasons it's gonna be deprecated. So we specified the new row that we wanna be appending. Let's create actually a data frame out of it. So you can create a new data frame using a dictionary, just like that. So you put new row inside of the wrapper pd.dataframe. And let's concatenate. So you use pd.concat tmp.df access equals to 0. Okay, so let's talk a little bit about that. The .concatenate can concatenate two data frames or a data frame in a series into one data frame. So what you pass as the first argument is an iteratable that contains either series or pandas data frames. In our case, we have a list of two data frames, and we say that we want to concat them line by line. So what this will do is get the temporary, what this is going to do is get the TMP data frame, and for each row of the data frame called df, it's going to be appending rows, and it will return a new data frame. So the result will be a new data frame. One of the problems of the new data frame is that the indexes are all messed up. Both the TMP and the first element of df have the same index of 0. So first of all, in order to fix it, we use ignore index equals true. So it's gonna create a new index on the final data frame, and you can see that this is fixed. Also, we have not saved the new data frame into a variable. So let's call this df3, print df3, and we have saved the new data frame in this variable df3. And let's see after that how you can remove a row in the data frame using the index. You can use df drop index equals 0. So what is this going to do? It's gonna go find the index 0 and remove it. Let's run this code. Oh, it removed from the original data frame. So we want to drop actually the index from this data frame. Okay, df3, boom, the index is removed. Okay, let's print out df3 again. Oh my god, df3 actually still contains the first index. Okay, so how are you gonna save this? You wanna go here and put in place equals true. Okay, so now df3 is gonna change because we use the operation in place. If you do not use in place equals true, it's just gonna and return a new object like df3, but having removed this index, the index 0. All right, So this is how you can also drop rows from a data frame. And there is also another amazing way. For example, you can also use a filter operation. So for example, let's say field equals df where age is over 30. And what you want to do here is use the index. So okay, let's talk a little bit about what this filter operation does. So first of all, it's gonna go inside df3, specify df3 please, and it's gonna look at the age column, and it's gonna return a false value for each index where df3 is not bigger than 30, and the true value where df3 age is over 30. So it will be false, true, true. So if you use the dot index, you can actually access the index of a data frame. So the filter method here, it will have the indexes of second and third, because these two will be true. If I print this out, check it out a little bit, it will also return, it will only have the elements of df3, 2 and third. If you use the dot index, you just get the indexes of those two elements. So if you go back up and use the df3 index, instead of this index, you can use the field index. Oh my god! You can actually drop the second and the third index by using this operation. Let's run this. And it will be done also in place, which is absolutely amazing. Boom! Our data frame now has only the first index, or let's say index equals to 1, and those elements, all the others have been dropped. So this is how you can use a filter method to drop multiple rows.